6-20, and I've done 619. We're gonna, instead of using the chart in the back and whatnot, we are gonna learn how to do these using the Excel program. Okay, we might take a look and compare it to what's in the back as well. But 619 says this. It says in a binomial distribution, n's equal to 8, my probability is 30%. Find the probabilities of the following events. One is that x is exactly equal to 2. Well, you know, if we went and looked at our chart and we got 8 is my n and 0.30, and so exactly 2, I should end up at 0.296 if I'm not mistaken, and that's what I end up with. Well, how can I do that? I'm going to do it over here because this one gets to be a little bit complicated. I want to make sure I come up with the same answer, so I'll go to insert function and maybe go to statistical. You don't have to scroll down very far and you see binom dot distribution. Okay, returns the individual term binomial distribution probability. That's what we want. Okay, got to kind of read these instructions as you go through this. Okay, otherwise it gets to be, for me anyhow, a little bit difficult. So this one says return or number S is the number of successes in the trial. So I got eight total, right? But I'm looking for exactly 2 successes here. So I can click on my 2 because I've input all my stuff up here nicely. Okay, and then the number of trials is my n. Okay, and then my probability is my probability, which is in this case 0.30. And the last one, is it cumulative? Now, our next question, we're going to get into a cumulative question, but for this one it's not. Okay, this one's not cumulative. Okay, and so it says for the cumulative distribution function use true, for the probability mass function use false. You can actually use a 1 for true and a 0 for false. So I'm going to put false in this case. Okay, and I come up with the 0.296, the same thing that I found when I looked back in my chart, right? 0.296 right there. Okay, so my next one then asks me, well, what's the probability that x is less than or equal to 2? Okay, so it could be 0, 1, or 2. And there's probably a couple different ways I could do that. One, I could go and look at my chart, and I could add these ones up. 0.58 plus just about 0.2, so I'm about 0.24, you know, plus about 0.3, so about 5.4 or 0.54, somewhere's in that neighborhood, and I could certainly put this into, you know, Excel and then just add them up easily that way. I got 0.55, so I think my math was relatively close that I was doing in my head, but this is where that cumulative one comes in as well. Okay, so again, I'll click on that and I'll come to the binomial distribution, and my number of successes is once again 2, my trials is once again 8, my probability is once again 0.3, and in this case it is cumulative, right? Because I want to know 0.1 or the probability of 0 plus the probability of 1 plus the probability of 2. Okay, I want to know all 3 of those, and so I can enter a 1, and that brings up my answer. Okay, then it gets to be a bit more difficult, I guess, because then it says greater than or equal to 3. Okay, this could also be put in as greater than 2, but not equal to 2, but in this case it's greater than or equal to 3. Well, these probabilities always add up to 1, right? If we go and look at that, you know, if we take a row here, that's going to add up to 1. And one way we could do this is that we could take 3 and we could add all the rest of these up. You know, we could put this into our Excel spreadsheet and add 0.254 plus 0.136, so on. And we would get the correct answer that way. Okay. But the other way to do that is that if this is less than or equal to 2, okay, then everything above that is going to be 1 minus, right? Because our probabilities always equal up to 1. And so in this case, I want to know x is greater than or equal to 3. So it's basically the inverse of that one. And so for this particular one, all I have to do is say that this is equal to 1 minus this. Okay. I don't know that there's a binomial distribution that would do, you know, the cumulative otherwise, and so I think we have to use this inverse formula when we're doing that, and they'll ask some questions kind of tricky. In this case, they asked them all together, right? But what if they hadn't asked this question? Okay, would you have known then to do? You'd have to think about that. You'd have to know in this case to do a less than or equal to 2 and then do the inverse. So you got to be thinking about that as we move ahead to some other problems. There is 6-20.